Hey guys, so today we're going to be working on the Pulley problem on an incline from the Long Kappa problem set 7. Alright, so here we have a mass connected to a pulley on an inclined surface connected to another mass with a force pulling it in the positive x direction. So the problem gives you that mass 1 is 6.6 kilograms, mass 2 is 1.7 kilograms, and the force that is pulling on mass 2 is 22.8 newtons. And so what we're trying to find in this problem is what is the magnitude of the tension in the connecting cord. So basically we're trying to find Ft of this cord. So we are going to draw the free body diagrams for both M1 and M2. So for M1, it's just on a flat surface. We're going to have, and really we only care about the ones in the x direction because we're talking about the tension of the pulley, which is also in the x direction. So for M1, we have Ft, and that's pretty much it. And so we know that F equals Ma. So, and this is going to be Fx is equals Max. So, because since it's in the x direction. So we're going to set this Ft is equal to M1. And that's going to be important for later. So now we're going to do the free body diagram of M2 as a small box. I'm going to make that bigger real quick. There we go. So we're going to have the force of here that is pulling on the box, and then we're also going to have the force of friction. Wait, just kidding. The surface is frictionless. We're going to have the Ft right here going in this direction, and we're also going to have the gravity in the y direction, or in the x direction. It's going to be mg sine theta. Okay, so for this we're going to have F, if this is our coordinate axis, we're going to have F minus mg sine, anyway, actually let me put it this other way. F minus f sub t minus mg sine theta is equal to m2a, because it's basically the long version of f equals, or f sub x equals ma x for mass 2, which I forgot to label here, I apologize. All right, so we know that ft equals m sub 1 a. So what we're going to do is we're going to replug in. So f, we have f right here, and then f sub t is we're going to plug in this m1a. So f minus m1a minus mg sine theta is equal to m2a. And what we're going to do, I'm going to move this to the other side. So f minus mg sine theta equals m sub 1 plus m sub 2 times a, once you break it all down. So now we're going to need to find acceleration to plug back into here so we can find tension. All right, so we're going to do f minus mg sine theta over m1 plus m2 is equal to a. All right, so now we're going to plug all this fun stuff in. Draw a little arrow here. So F we have is 22.8 newtons minus, we'll put big brackets here, mg, so mass times gravity, and this is mass of m2, by the way. So we're going to do 1.7 times 9.8. You can do 9.81 if you'd like, doesn't really matter. Sine of the angle, which is 31.3 degrees. I'm going to put that all over m1 plus m2. So that's going to be 6. Sorry about that. My neighbor upstairs is doing something annoying. So 6.6 plus 1.7. And all right, let me plug that into my calculator real quick. 2.2, or sorry, 22.8 minus, let's see, 1.7 times 9.8 sine 31.3 divided by 6.6 plus 1.7. I'm going to get acceleration is equal to 1.704 meters per second squared. Awesome. So now what we're going to do is take acceleration, plug it right back into m sub 1a. I mean, you could plug it into here for this, because then you will calculate the f sub t, because what we're dealing with right now is these strings have the same tension on each side. So maybe later in different units we'll have to do it differently, but for now we're going to do the ft is the same on each one, so we're going to plug it into the easier equation. So f sub t is equal to m1, which is 6.6 times 1.704. 0.6 times 1.04, and that is equal to 11.25 newtons. Yeah, and that'll do it for this problem. I hope this all makes sense for you guys, and good luck.